Hello everyone. Now we will see one university question and answer on calculation of slope and deflection. This university question is in the year May 2016 for Annamalai University. It is a simply supported beam of span 5 meters loaded with one load 20 kilonewton at center. Now we have to calculate the maximum deflection, that is at C, and also the maximum slope, that is at A. We have to calculate the slope at A, that is theta A. We have to calculate the deflection at C, that is theta C. The other given data are moment of inertia is equal to 12 into 10 power 6 millimeter power 4, which is equal to 12 into 10 power minus 6 meter power 4. We have to be consistent with all the units. So we will convert everything into kilonewton or meter. The moment of inertia is converted from millimeter power 4 to meter power 4. Similarly, the Young's modulus E value is given as 200 gigapascal, which is equal to 2 into 10 power 8 kilonewton per meter square. Now, what is stated by Mohr's first theorem? If theta A and theta C are the slope at the 2 points A and C, then theta A minus theta C is equal to 1 by EI times area of the bending moment diagram between A and C. Now, this beam is loaded with 120 kilonewton load at center. Therefore, the reaction is 10 kilonewton at A and 10 kilonewton at B. Now the bending moment diagram is drawn here. It is a triangle of this shape. The bending moment at any distance x from A is equal to 10x, because 10 kilonewton is the reaction. Bending moment at a distance x from A is 10 into x, 10x. You consider a strip of width dx. This is the bending moment diagram. You consider one small strip of width equal to dx at a distance x from A. Area of this strip is 10x into dx. Now, for getting the area between the points A to C, we have to integrate this small strip area between the limits A and C. So theta A minus theta C as per Mohr's theorem is 1 by EI times area of the bending moment diagram. Area is 10x into dx. It is integrated between A and C. So the lower limit is 0, upper limit is 2.5. Theta C is equal to 0 because of the symmetrical load. This is the deflection curve. In the deflection curve, if you draw a tangent at C, it will be perfectly horizontal. That means slope at C is 0. So theta A minus theta C is equal to theta A. That is theta C is equal to 0. So theta A is equal to this much. We have to substitute the values of E and I, which we have already converted in terms of meter power 4 and kilonewton per meter square. And this is the area after integration between A and C. And then we get the slope here. This is theta A. Now we have to calculate the deflection at C using Mohr's second theorem. What is stated by Mohr's second theorem? If A and C are the 2 points on the deflected shape, then the vertical intercept between the 2 tangents is given by the area of the moment of the bending moment diagram between the 2 points. Suppose you consider the points A and C. From A you have drawn one tangent. From C you have drawn another tangent. This is one tangent at A. This is one tangent at C. Drop one vertical. This is the vertical intercept between the 2 tangents. This is YA. And this YA happens to be equal to delta C, which is the deflection at point C. Please note, the deflection value is not given by Mohr's theorem directly. Mohr's theorem gives only the vertical intercept between the two tangents. YA happens to be equal to delta C, and we have to calculate YA. That means the area of the bending moment diagram between A and C, we have to take the moment about the point A, because we need the ordinate YA. Please note, we should not take area of the bending moment diagram between A and C about the point C. If you take moment about the point C, it will give the value of the vertical intercept between the two tangents, which is below C, and it is in no way related to delta C. Delta C is equal to YA. Therefore, we have to take the area of the bending moment diagram between A and C about the point A. So this is what we have written. Delta C happens to be equal to YA, which is the vertical intercept between the two tangents drawn from A and C, and that is equal to 1 by A times into area into distance. Area we have already calculated. Area of the strip is 10x. The ordinate dx is the width of the strip. This is the area, and this strip is located at a distance of x from A, so multiplied by distance x. So this is the moment of the area of the bending moment diagram between A and C. The limits are A and C. So the lower limit is 0, upper limit is 2.5. And after simplification, we get this term. We have to substitute the values of E and I, and we get 0.0217 meter, which is equal to 21.7 millimeter. Now, I am requesting you to visit this website, answer-Mohr.wordpress.com. Here you have plenty of university questions and answers. This question is also found in this RGN site, wordpress.com. The download is free. There are so many explanatory questions. How to calculate the area of the bending moment diagram, why we should take moment about a particular point. All these things are explained in the form of questions and answers. You will have plenty of university questions and answers on various topics: RCC design, steel design, strength of materials, structural analysis, volume 1, volume 2, etc. Somewhere around 25 university questions and answers are given in matrix methods. Some 20 university questions on moment distribution method. Many university questions and answers on strain energy method, RCC design, steel plate girder, steel beams, etc. All these things are given in RGN site.wordpress.com, and the download is free. I am requesting you to forward this to your fellow engineers and students so that all of them are benefited. Thank you.